So when do we say a sequence is convergent? If I say xn converges to x, can you define it? What is the definition without looking into your book or anything? When do we say xn is convergent to x? Yes, anyone? Or you can also write this as limit n tending to infinity xn is equal to x. Yes, you can write either for given epsilon positive or for all epsilon positive. Correct? What is the condition? There exists and not belongs to, yeah, there exists and not belongs to natural number such that satisfying, you can say satisfying. Okay, n is greater than equal to n naught. Imply, what should it imply? If you want, you can write bracket open like that. What should it imply? Xn minus x must be less than epsilon. What do you mean by this? X minus epsilon and x plus epsilon. Perfect. So graphically also we have understood what is the meaning of this, correct? What you have to start with, you have to first draw where is x, correct? So suppose this is my x. What else we have to see? Will be given with one epsilon value. Suppose epsilon का कुछ value दिया है, then what you have to do? You have to create a epsilon band. How will you do that? By taking x minus epsilon. ये x है तो x minus epsilon will be somewhere here, and somewhere x plus epsilon it will be somewhere here. So let us make a band. So this is a epsilon band around x, correct? Now what next? Now you have to put the points. Suppose first point is here, second point is third, fourth, fifth, sixth, seven, eight, like this, like this. Points are then after some time, all the points are lying in this band only. Okay. Then what is our conclusion? If all the points are lying in the band, then you need to just find a knot which after which everybody is lying in the band. So you must choose either, you must choose this as a and not, correct? So what is the conclusion? You need to find a n naught such that after n naught everybody is lying in this epsilon band. This is the definition of sequence is convergent. So give me any epsilon, I'll be giving you an n naught such that all the people are lying in this epsilon band. That's it. Correct. So this is graphically, if you understand it properly, then done. You don't have to worry about it improving anything. Okay. So let us define one more new term, not new to you because you have already encountered it in your first unit. Bounded sequence. A sequence xn is bounded above if there exists a m belongs to R such that xn is less than equal to m. Hmm, what happened to this now? What is the condition? Every sequence is less than equal to m, then m is called an upper bound and the sequence is bounded above. No, it all vanishes now. I'll write once again. Hmm. Bounded sequence, a sequence xn is bounded above if there exists m belongs to real number, oh, belongs to real number such that xn is less than equal to m for all n belongs to natural number. For all n it should be true. Okay, and the number m is called upper bound. M is called upper bound of sequence xn. Okay, same as in the case of unit 1, correct? Similar to this, one more definition would be a sequence xn is bounded below. What will be the condition? Can somebody tell me? Bounded below if there exists small m belongs to R such that, what will be the condition? M must be, yeah, correct. Small m is less than equal to xn, that is also okay. For all n belongs to natural number. And when do we say, what about small m? Small m is called lower bound. Lower bound of sequence xn. And when do we say the sequence is bounded? Yeah, when it is both bounded above and bounded below, correct? Yeah, good. So I'll write it in the next page. A sequence xn is called bounded sequence if it is both bounded above and bounded below. That is, mm, that is, there exists small m and capital M belongs to R such that xn is lying between small m and capital M. Do you remember in the unit 1 I have given you one more definition of bounded set, if you remember? Is the both the definition are same? Can I say that? Do you remember? I think मैंने unit 1 में बताया है ये. You want to prove both are equivalent. This definition is same as this definition. Can you see that? Can you prove that? We have proved it in unit 1. Can you do that? You need to start with this and you need to prove this thing. So what will you consider? You will consider the maximum of this thing, correct? And that maximum will be your that m, because mod of xn is less than m, less than equal to a. So this is same as minus m is less than equal to xn is less than m, no? That means what, it has lower bound also, it has upper bound also. So this is much better definition, better than this, correct? Because here we require two people, small m and capital M, but here we required only one people to prove whether it is bounded or not, correct? So this one is more appealing definition. We will be using it in proving something. If you want to prove something, and this will help us. Is that clear? Is the definition clear? Yeah. Okay, now I'll be giving some sequence and try to see what are the bounds, what are the upper bound and lower bound. Let us take first xn equal to 1 by n. Can you give me the lower bound and upper bound of the set? If you remember unit 1 में ये सब कुछ किया है हम लोग ने, but at the place of xn I used to write it is a set. What are the lower bound and upper bound? Lower bound, do you see, since n is positive, okay, n is positive, so what about 1 by n, that is less than equal to 1? Is that clear to you? So 1 is an upper bound, do you see that? That is xn is less than equal to 1. And can you give me a lower bound? Will this term be 0 anytime? It is going towards 0. Will this be 0? No. So do you see the lower bound? 0 is my lower bound, 1 is my upper bound. So can I see that xn is bounded? Can I see that? Or can you give me another lower bound? Can you give me another lower bound? Anybody less than 0 is also my lower bound. Do you agree? Yeah, so negative numbers are also my lower bound. And anything greater than 1, they are also my upper bound. So I just wanted the least one, the greatest one, something like that. So this is greatest lower bound, that is least upper bound. That is GLB and LUB, if you remember. But here I'm not introducing those concepts. I'm just simply saying whether it is bounded or not. Is that clear? Okay, let me ask you one more question. Yeah, tell me the lower bound and upper bound for this. In the previous one, I have given you a hint how to start. Can you see lower bound as 0? This will be neighbor 0. Even negative people are also my lower bound. I just wanted one lower bound. So 0 is my lower bound. Can you see that? Yeah, and can you tell me the upper bound for this? 2. Anybody else? Do you agree with her? Yeah, perfect, good. So but you need to prove, you cannot directly say कि हाँ भाई 2 है. Lower bound is quite okay, that is, this is always positive, but you want to see this has a upper bound 2, so how will you do? You need to see your n plus 1, correct? Your n plus 1 is always greater than equal to 2. Do you agree? Because your n is natural number, so it will start from 1. So 1 plus 1 it will become 2, then it is equal, and otherwise it is always positive. It is always greater than. So what about 1 upon n plus 1? That is less than equal to 1 by 2. But we don't want this. We want 4 also. No? So multiply by 4 both the side. So 4 upon n plus 1, that is less than equal to 4 by 2. That is same as 2. So we are having both lower bound also and upper bound. So what are the lower bound? 0. So it is 0 is less than xn is less than 2. Do you agree? So it is again bounded. What are the upper bound and lower bound? Lower bound is 0, upper bound is 2. Nice. So here I am proving, huh? Earlier we were just looking at the set, ki how they are, and then we used to decide ki lower bound upper bound kya hai. But here we are proving that. Okay, let me ask you. So what is the conclusion for this? This is bounded. What about this one? Is this bounded? Okay, let me take one more. Xn is equal to 3n square plus 2. Can you quickly give me lower bound, upper bound if exist? Lower bound exist होगा, and what about upper bound? Okay, does not exist. What is the lower bound? Phi. Do you agree? And can you prove that? How will you prove? प्रूव पूछ रहा हूँ मैं, अभी पुटिंग थोड़ी होता है वो. You can say one more thing, sir. This is increasing sequence. Do you see increasing? मतलब अगर मैं sequence नहीं define किया, I can say this is increasing function. If I put n equal to 1, it is giving me phi. If I put n equal to 2, it is again something else, but it is bigger than phi. Do you see? If you put n equal to 2, then this will be. So it all the time when I'm putting some value of natural number, it is always going away. Correct? It is increasing. That is also a conclusion, or you can say like this. See, n square is always greater than equal to 1. See, I'm trying to build this in all the cases. In the previous one also, I just wanted to build this one. So I started with n plus 1 and something like that. So this is what you have to see. So n square is positive. What should I do now? What should I do now? Perfect. Multiply by 3. So this is 3n square is greater than equal to 3. What next? What do I want to? I want to build this. So I have to add 2. So 3n square plus 2, that is greater than equal to 5. So we are having lower bound as 5. But this is never going to end somewhere, or there is no pool which will restrict this guy. Correct? So this has a lower bound 5 but does not have an upper bound. So what is the conclusion? Whether the sequence is bounded or not? Perfect, not bounded. Okay, one more simple one. Yes. What about this one? This is minus 1. Bounded. What is the lower bound and upper bound? minus 1 is the lower bound and upper bound is 1. How will you say that? You have to write that thing. How will you do? ऐसे थोड़ी बोल सकते हो सर वो तो देख रहा है ऐसा. You can say range of xn is minus 1 and 1, which is bounded set, correct? It is not taking any other value other than this. So this is the same as, so what is lower bound? So you can simply say xn is between minus 1 and 1. If you use this word, then you're done actually. You can directly say that minus 1 is less than equal to xn is less than equal to 1. Okay, is that clear to you now? Yeah. So I hope this concept is clear to you. Let me go ahead with next one. Monotonic sequence. I'll directly write, you try to consider that we are dealing with real valued sequence, so I don't require all the time that xn is a real valued sequence, something like that. You should understand since we are doing that thing only. Okay, so if xn is less than equal to xn plus 1, or xn plus 1 minus xn is positive, then we say that xn is monotonic increasing sequence. Sequence. Do you understand that? If xn is less than equal to xn plus 1, और इसको उस साइड लेकर गया, that means xn plus 1 minus xn is greater than equal to 0, then you will say that xn is monotonic increasing sequence. What about the next one? क्या आएगा वो? Monotonic decreasing. So in that case xn will be greater than equal to xn plus 1, or xn plus 1 minus xn must be negative na, correct? Then we say xn is monotonic decreasing. Mostly I'll be using this notation for decreasing and this notation for increasing. Monotonic increasing, monotonic decreasing. Okay, and when do we say a sequence xn is monotonic? Okay, so my question is that can a sequence be both monotonic increasing and decreasing? Can you give me a sequence which is monotonic increasing also and decreasing also, both the thing? तो n plus 1 रहेगा तो क्या होएगा? Let me take your example. So if xn is n plus 1, now I want to check whether it is monotonic increasing or decreasing. The best thing to use this definition, this or this. So you try to solve this xn plus 1 minus xn. Let us start with xn plus 1 minus xn. So what is your xn plus 1? Xn is n plus 1. If you put n की जगह पे n plus 1, so this will become n plus 1 plus 1 minus what is your xn? N plus 1. Do you see? So this is n plus 2 minus n minus 1, so n cancel, it is giving me 1, which is a positive number. So what is your conclusion? Positive, that means what? Xn plus 1 is greater than equal to xn, that means what? It is monotonic increasing, na? Do you agree? Hello, do you agree? I wanted to check whether this sequence is monotonic increasing or decreasing. This was my question. Check. Okay, so this was my question. Check whether the sequence is monotonic increasing or decreasing. So this was my sequence given to me. So what is the definition to check whether it is monotonic increasing? You just need to solve xn plus 1 minus xn. If that is positive, then you say that sequence is monotonic increasing. If that term is negative, then you say that it is monotonic decreasing. So it is better to solve this thing, na? Correct. So this is why this is what I started with. I started xn plus 1 minus xn. So that is equal to xn is n plus 1. So what will be xn plus 1? If I put at the place of n, if I put n plus 1, so this will become n plus 1 plus 1. That is what I wrote here. N plus 1 minus xn, that is n plus 1. So just solve it and I am getting 1, which is a positive number. That means xn plus 1 minus xn is positive. That means the sequence is monotonic increasing. Do you agree? Okay. So let me ask you one more question. Xn equal to 1 by n. Check whether this is increasing or decreasing. How will you start with?